Hello viewers, thank you for visiting again. So we'll continue our hands-on for the topic designing and implementing a data science solution on Azure. Today we'll be starting hyperparameters tuning, and I've opened this link in a new tab. So what is hyperparameter tuning? Hyperparameters are variables that affect how a model is trained, but which cannot be derived from training data. Hyperparameters are basically those variables which, if you tweak, our trained model will perform better or reach to a perfection, uh, and also it will reduce the bias of our model. Okay, so to do that, we have to do some trial and error, because hyperparameter tuning we cannot derive from the training data. So we have to do multiple runs on data to train our model and see which one is for which set of data or for which set of hyperparameter variables it is performing well with low or no biasness. Okay, so basically accuracy increases and also biasness decreases when we try to tune the hyperparameter. That's our goal basically. Okay, now to do that, in Azure Machine Learning Studio we'll be performing multiple training runs in parallel and try to see for which set of hyperparameter variables it is performing more accurately and with less biasness. Okay, so that's our goal. So there are prerequisites to do that. We have to create a Azure Machine Learning workspace and then open Azure Machine Learning Studio and clone the relevant hands-on notebook. That part I have already covered in my previous videos. So please go and have a look and then come back to start this hands-on. Thank you. So here I've already cloned my notebooks for this hands-on and I have started my compute instance. Okay, and here you can see my compute instance is up and running, and these are the notebooks that we have which are already cloned from GitHub. Okay, and I have opened the relevant hands-on notebook. Okay, so just code from the start. Okay, so there are many machine learning algorithms that require hyperparameter tuning. Okay, and parameter values that influence training but can't be determined from the training data itself. Okay, those are called hyperparameters. Okay, now when training a logistic regression model, you can use regularization hyperparameter, rate hyperparameter, to counteract bias in the model, right? Or when training a convolutional neural network, you can use hyperparameters like learning rate and batch size to control how weights are adjusted and how many data items are processed in a mini batch respectively. So for different scenarios, there could be different variables which could be tuned. Okay, and that process of tuning is called hyperparameter tuning. Okay, now the choice of hyperparameters values can significantly affect the performance of a trained model or the time taken to train it. Our goal would be to use multiple combinations of how our model is performing. Okay, so the performance would be one parameter, and then time taken to train our model would be the second parameter, and we have to, our goal is to optimize our solution which will have a more accurate and good performing model with less time to take, to train that model. Okay, Now, to do that, we have to create parallel experiments or parallel trained model which will be run, and then we'll be tweaking the two hyperparameters within our classification model. Okay, I will name it what those two hyperparameters are, and during the tuning we'll see for which set of values for these two hyperparameters our model is performing more accurately as well as taking less time to train. Okay, so first of all, we'll create or we will refer the workspace in which we are going to do all these experiments. So this will print our Azure Machine Learning package and the workspace which we are going to use to run our training, okay, and training of the hyperparameter. Here, now we are preparing the data set. From where we are preparing this data set? From these two diabetes files, set of files, which are comma separated values or CSV files. So from these files, we'll be uploading these files to our data set, and then we'll be registering those data set as a tabular data set within our workspace. And once registration is complete for our data set, we'll be able to see within the dataset section for those dataset values we can see in the tabular form within dataset section. Okay, now let's run this. So it is going to upload the files within our data store and then prepare a tabular dataset which will reflect in asset section. And the data it is uploading is from this data folder diabetes.csv and diabetes2.csv. From here, it is going to prepare the data set, which will be a tabular data set. Here you can see. Now, here you can see data set is already registered. That means we have already prepared the data set. Next, we'll be creating a experiment folder, okay, in which we will put all our Python script or artifact, which will be running and training the model. Okay, so folder is ready. So now we have already created this folder, empty training hyperdrive, that's our folder name, and within that folder name we are going to write a Python script which will have steps to prepare the data, and then hyperparameter variables, which is nothing but learning rate, and n estimator, which is number of estimates that we have to make. Okay, so these two hyperparameter variables I was referring earlier will be tuned, okay, while training our data set. Okay, and that data set is nothing but diabetes data set, predicting whether a patient is diabetic or non-diabetic, right? These are the fields or we have, the different parameters that we have for diabetes data. Here first we are trying to input the training data set. Okay, here we are setting the hyperparameters variables with 0.1 and 100 for number of estimates that we're going to make, and that's the learning rate. Then those will be also logged during the model run. Okay, so that's why we are trying to run log those within our execution. Next, input data set. So these pandas data frame from this training data will be set as input for our model. Before that, here we are labeling the data columns as well as splitting data into 70 and 30% of data sets. Okay, training and test data sets. Then we are utilizing gradient boosting classifier algorithm, which will take a parameter of learning hyperparameters as learning rate and the estimators, right? And then take the training data to fit the model and prepare the classification model. Then we will pass the test data set to predict how the model is performing. Then we will be printing the accuracy and the AUC scores to check the accuracy of the model, performance of the model, right? And then that model will be saved within the output folder. Okay, so this is just a script file. It will be preparing a script file within our experiment folder. So let's run it, and this script file will be written here. Okay, if you see here, so this is where this diabetes training script file was prepared. Then we will be calling this script to run the model. Okay, next we have to create a compute resource which can run training parallelly, okay, based on different hyperparameters, okay, different values of hyperparameter variables. Okay, so for that we are going to specifically create, okay, a compute resource, a dedicated compute resource to run this experiment. Okay, so here we are creating on-demand cloud compute and a cluster which can go from 2 nodes to two nodes, okay, or basically 2 instances of that cluster, okay, so that we can parallelly process the training and test data set. Okay, so these are the relevant packages we are importing to create a compute target, machine learning compute target. Okay, and here we'll be naming our compute cluster. So I can name it hyperparameter compute clusters. Okay, so that once the compute cluster is prepared, okay, we can pass our Python script that we prepared to execute within that compute cluster. Okay, so this is where we are going to create a compute cluster or training cluster. It takes help of the workspace and cluster name. If it does not already exist, then it is going to create a compute resource. If it is existing, then it will just skip that step. So here, to prepare the compute instance, we are taking this VM standard data science 11 v2 VM with 2 nodes. Okay, so if there is a huge load, it could create 2 instances of that cluster. Okay, compute cluster, and then we are registering that cluster within our workspace with the cluster name and compute configuration that we are trying to provision, right? Next, to run this compute cluster, we also within that compute cluster we have to prepare also a Python conda environment so that our Python script could run. Okay, so we are taking the help of a hyperdrive environment.yaml file where we can just put the dependencies, like which all the Python packages are required to run our Python script, right? This Python script or the training script. Okay, to do that, let's prepare this file. This file will also be written here. I'll refresh the page, and here you can see the environment file is also created. Let me open this in another tab. So here you can see this environment file is also ready. Next, run a hyperparameter tuning experiment. So that's where the last part comes. Like we'll be preparing a hyperparameter tuning experiment. So within that experiment, it is going to take the help of our Conda environment specification, diabetes dataset, our Python script, training script, compute cluster, right? So all these variables or the parameters are being set within the script run configuration. Okay. Now sample a range of parameter values. So this is where we are passing learning rate and estimators. Okay, right? So hyperdrive will try 6 combination, 3 into 2. Here we are putting 3 choices for learning rate and 2 choices for estimators. So total 6 combinations of learning rate and estimators it is going to try. Okay, for this Python script or for training or modeling. Okay, now within hyperdrive configuration, what we are putting run configuration, which we have prepared here, script configuration, nothing but it's taking the experiment folder from where we have to refer the training script, training data, Conda environment, training cluster, all these things. Okay, next. Then hyperparameters samples, which is coming from here. No early stopping policy. So it is not going to stop early until all the choices are exhausted. Okay, so all the choices combination will be utilized and run. Okay, find the highest AUC metrics, and out of that the goal would be to find the highest AUC. Okay, what it is doing, primary metric global dot maximize. So the goal would be to maximize the accuracy. Okay, and maximum total runs we are putting 6, which is 3 into 2, and concurrent runs are 2, that means run up to 2 iterations in parallel using the 2 nodes of our cluster. Now this experiment is prepared and it is going to run within our workspace with this name, micro ms learn diabetes hyperdrive, right? That would be our experiment name, and this experiment is being passed within the experiment.submit as a run job, and this is going to run and wait till all the jobs are complete. So let me run it. It is going to take a long time because it is going to provision everything, clusters, environments, and then try the parallel run for all these different choices. So let's run it. Till it's running, let's go get a coffee and then come back. Okay, training cluster is not defined. So let's put the training cluster. I have not run this. First, let's create the training cluster. Okay, that is also creating an issue. Let me check that. Okay, guys, I think the issue is with this name. It is looking for a 2 to 16 character long, and I have given more than that. So let's run it again. Okay, so now it is provisioning a VM. Okay, and that would be our cluster prepared. Once the cluster is prepared, we are referring the same cluster name here. So that's why the issue, actually the cluster was not provisioned. So we came to this error. Okay, so let's first the cluster gets created. Okay, and then, okay. So now the number of nodes request has been provisioned. This cluster is created and succeeded. It is showing the status. So once the cluster is created, we will run it again, and it is going to take a longer time because it is going to do parallel runs, provision the cluster, then environment, everything. So so let's wait for its execution. You can see the status within the widget. Okay, notebook widget, and all the logs being printed from the execution. Okay, once the execution completes, okay, we'll be printing all the child runs and we'll be sorting the matrices. Okay, based on the accuracy argument. So best run ID will be returned here. Okay, then it will return the AUC for that run ID, accuracy percentage, and the arguments that we passed, which gave maximum accuracy of our model. Okay, so all these parameters will be printed once our experiment completes. Okay, here you can see the run 3, 2, right? So different runs being printed. Okay, and these are our run IDs with the different learning rate values also printed in the form of table. Okay, so let's wait till all these executions complete. Then I'm going to show you the result. Okay, so now we see, so 5 of the instances have been completed and the 6th one is queued. Okay, 6th one is also complete, and we can check the best metrics, right, from this table to see which one has performed more accurately. And here we can see 0.9876%, which is almost 99% accuracy with very less time. Okay, so as I mentioned earlier, our goal was to get a model or train a model which is more accurate and also taking less time to train. And the hyperparameter tuning variables and their values are, you can see the learning rate is 0.1 and n estimator is 10. Okay, so based on these two values, our model is giving the most accurate result. Okay, not this one, just a minute, let me refresh it again. So this one, 1 and 100, learning rate is 1 and 100. Okay, and these are all the plots for that. Okay, scatter chart. We can also change the matrices or parameters to check the respective values. Okay, next, this is where our experiment is complete. We have got the notification, and let's move on to the next one. Here you can see all the logs file printed, the cluster that we provisioned, right, our cluster name where all the experiment was run. Okay, so all these different logs are printed. Okay, now let's print which training model performed best and for what values of learning rate, right, and estimators. Okay, so let's run and see which one performed better. Okay, so this is our run ID, which gave most best accuracy for 0.1 learning rate and estimators as 100. Okay, here you can see, right, best run ID is this one, ending with _3. Okay, and it gave 98, almost 99% accuracy. Okay, 98.8% accuracy. Sorry, AUC score accuracy is 94.6%. Okay, next, so this is how we can tune our parameters for different models and see which one is performing best to train our model. Okay, we can also register the model, okay, within our workspace for the best trained model. Okay, and here you can see this is the accuracy and AUC score, and the name is hyperdrive for this training context. Okay, this is the latest model. Our model version is 6 with highest accuracy as of now. Okay, within all our model which we have trained earlier, you can see. Okay, So that's it. This is how we are going to tune our parameters, run the parallel experiments, uh, and see which model performed best. Okay, so that's all for now. Thank you for watching. Please like and subscribe my videos if in any way these videos are helping you. Thank you. Bye bye.